So how do z-scores help? So now, my average score is 48 and the standard deviation is 22. But if I want to get a sense of, on a normalized basis, how do these numbers look like? One possible mechanism is to go out and generate a histogram. I can do that in the raw scores also, but there's a reason why I'm using z-scores. So if I do a copy and I extend this, take it all the way here. What I'm going to do next is I have this data set. I'm going to go out and sort this so you can get a sense of what do the numbers look like, what are the highest scores and the lowest scores. So I'm going to sort column AD. I don't have to do that, but I'm going to still do this largest to smallest. So the highest Z score for week 1 was a relative score about 2.05. And there were about 3 students who did that. And then if I convert this into a histogram, how do we do that? We go to data, we go to data analysis, then we click on histogram, we press OK. We plug in our data series. So our data series is here, which is 2.05 all the way till 2.18. And then we say, give me cumulative percentage, chart output, and a new worksheet plan. And I press OK. And when I press OK, Excel goes out and does the calculation. It's going to take a few minutes to generate it for me. And I now have the distribution. So I'm going to expand this, reformat this so that you can all see it. So that's one. If I go to chart design, I go to chart design here, and then I go to home. I increase the font size so you can see what's happening. Then I go back here and I format this. So this histogram is the relative distribution of grades and scores for a specific section or for the entire batch. What does this indicate? This gives us a sense of what does the scores look like. So on a relative basis, you can see that the biggest slice is at about 0.54, and then the second big slice is about 0.23. If you look at the overall distribution of scores, you would say that of the 200 students, about 116 students have scored above the average. Whatever that average is, right? And that's one benchmark. So now if I want to get a sense of, this is what we did in week 1, by the time we got to week 3, did the performance of the batch improve? Did the scores of the batch improve? And how would we answer that question? We would need to repeat the same calculation week 1 hist. You need to repeat the same calculation for week 3. So I'm going to go back to week 3. I'm going to repeat the same calculation, the same process again. Okay, so now we have week 1 normalized scores. Now we go to week 3 normalized scores. Now week 3 normalized scores, how do we calculate those? You guys tell me, what's the first step? So I've got these values, which is 44.44. What do I do? I subtract, what do I subtract? I subtract the mean, the average, which is 57. And then I lock it so that it's anchored to that one cell, and I can copy and paste it. Then I open and close brackets, and then I divide this. And what do I divide it by? I divide it by the standard deviation, which is 24. And that gives me a z-score of -5. Now, why is it negative? It's negative because 44.44 is less than 57, and the difference between the two is about half a standard deviation. So this student who scored 44.44 is about half a standard deviation below the average for the group. And remember, what is the objective of analysis? What are we trying to do? We're trying to get a sense of, has the distribution shifted? So now, why did I get these divide by 0 and value errors? I got these errors because in my haste to copy and paste, I refused, or I forgot, or I did not effectively log in M2. So if I press Fn M2, that should fix that problem. And now when I press and extend this, there you go. So you've got your values sorted. Now what's the next step? Now I don't have to copy all of them. I can actually just go to the histogram from here. So I can just go straight to data. I was doing so, I wanted to show you how it's done. I go to data analysis. I can go to histogram, press OK. And then in the input cell range, just need to go back and define this value from here, this set from, so column n all the way from beginning to end, and then I press OK. Cumulative percentage, chart output, new worksheet apply, and I press OK again, and Excel will go out and generate the histogram for week 2. Standard work, we're going to expand this, reformat it, increase the size. What do you think has happened? Do you think it's shifted? Do you think things have improved or they've become worse? If you were evaluating performance across week 3 and week 1, has the performance improved or regressed? So if you remember, we said this is one possible benchmark. How many students in the class were above the mean? That's one benchmark that we're looking at, and that number is the sum of this list, and this number is 138. You've got a plot for week 3 and you've got a plot for week 1. The easiest way to compare these two plots is to compare them side by side. So I'm going to go out and create a new slide here. And I'm going to copy and paste, and let me add week 1. So if I maximize this a bit, your distribution sort of peaks at 0.54. Week 3 here is less laid out, but still at about 0.58. So the biggest slice is still 0.58. And if you look at the tables that come out of the Excel histogram distribution, you get a better sense of what the numbers look like. So now again, this is analysis. How do we get to this analysis?